Okay, now straight up, based upon that simple picture, you should be able to see there's a difference between the greenhouse effect and the enhanced greenhouse effect. And if you're paying attention, right there, less heat escapes into space. So there's two distinct things going on. There's the greenhouse effect and there's the enhanced greenhouse effect. And when you hear the word enhance, usually it sounds positive. This is not positive. And notice here, what do we have? These gases, more greenhouse gases, carbon dioxide, methane, nitrogen oxide. So straight away we start to realise that there are gases that capture heat, and it goes from there. So there is a natural greenhouse effect, but we are talking about the enhanced greenhouse effect. Our key learning intentions, we're looking at causes and effects of the enhanced greenhouse effect, human activities that contribute to climate change, biodiversity, and outline the effect of climate change on sea levels and biodiversity. There are some greenhouse gases that you'll need to be familiar with. Now, there we go. We've already looked at the atmosphere in terms of the biosphere, and the atmosphere is important because it provides protection from the sun. The sun puts out some very damaging electromagnetic radiation. UV, X-rays and gamma rays are all ionising radiation that will damage DNA, and the atmosphere protects us from that. So yay atmosphere. But the greenhouse effect is when greenhouse gases trap the sun's warmth, and that means conditions are warm enough to sustain life. The Earth would be minus 18 degrees without an atmosphere. So the Earth, at the same distance from the sun, would be well below freezing if there wasn't an atmosphere capturing the sun's energy, or not quite capturing it, it's trapping the some of the sun's energy for a little longer. You can see solar radiation coming in, and then thermal radiation reflecting back into space, but some of that hits the atmosphere and bounces back down again. Okay, and so it's some of that energy sticks around longer than it otherwise would, and that is enough to keep the Earth's temperature high enough that we have liquid water and therefore life is sustainable. So that is the greenhouse effect. I haven't listed the greenhouse gases here yet, but we'll get that on the next slide. Okay, is everyone clear on that and where we are? So that's the greenhouse effect is really important for life surviving, but this is the enhanced greenhouse effect. Not the graphs, no. You should be familiar with these ideas. Now, it's also called anthropogenic climate change, meaning man-made climate change, or man-made global warming. Global warming's sort of the everyday term that people use. Okay, human-released greenhouse gases, carbon dioxide, methane, nitrogen oxide, and water vapour. By the way, water vapour is a greenhouse gas. Lead to additional heat being retained in the atmosphere, and this has an impact on climate because that additional heat changes conditions enough that climate is impacted. And we've looked at some of these graphs before. You can see this one here from 800,000 years ago. You've got this pattern of carbon dioxide concentrations. We know this, that carbon dioxide is normally around 250 parts per million for the last 800,000 years. And then since the Industrial Revolution, we've shot to about here. We're actually a little over 400 right now, but potentially, if unaddressed, you'd get this ludicrous scenario of 900 parts per million by 2100, and that would result in really devastating climate change. Now, yes, some people have rightly said that fossil fuels, if we burn fossil fuels, we're just returning carbon dioxide to the atmosphere. It used to be there. True. 60 million, 80 million, 100 million years ago, there was 1,000 parts per million of carbon dioxide in the atmosphere. And there was plenty of life on Earth. Absolutely true. But the oceans were 60 metres higher. The weather systems are completely different. 60-metre higher oceans would destroy every major city we have, and all of our farms would be in the wrong places. All of our settlements that weren't on the ocean would also be in the wrong places. We've set up things because we rely on the weather to act in reliable ways. Our farms are here because they know they get pretty good rainfall, you know, from year to year. There's some ups and some downs, but you know, that's where the farms are, that's where the cities are. And if you change weather systems, then you end up with odd things happening, and really devastating changes could occur, like monsoons not falling in Asia, where 3 billion people need them. Okay, and of course you've seen this before. This is a shorter scale of time, and again, this is temperature. The temperature anomaly from 1800. So temperature usually flicks around this 0 point. That's the average. But since the 1800s, the late 1800s, this average global temperature has gone up by about 1 degree. Okay, and I will emphasise this point. When people hear 1 degree, they go, "It's 27 outside." But if it was 26 or 28, I literally wouldn't be able to tell. Okay, but 1 degree over the size of the atmosphere is an enormous amount of energy, and that can do things to change weather patterns. Okay, and that can result in more evaporation occurring, which means more water vapour inside storms, like the one that just hit Florida, and you know, more energy driving those storms. So you get heavier amounts of rain and more severe winds associated with it. Now, let's have a look. Is everyone clear? So you've got your gases: carbon dioxide, methane, nitrogen oxide, and water vapour. All good there?
Yeah.
Okay. Now, there's some additional information for you. We've seen that little graph before. This is in centigrade, which is nice, and slowly but surely, over time, the average, and you'll notice the temperature increase tends to concentrate around the poles where the polar ice caps are. And that's Arctic sea ice extent over time. Sure, now you've got to understand that a warmer environment associated with climate change can result in heavier rainfall, can result in heavier snowfalls, because you get more evaporation. So if that evaporation comes down as snow precipitation, then you can get very heavy snowfalls. So, you know, global warming could result in colder winters in Europe, and we'll talk about that. And so you see every year the amount of ice, you know, during winter, the amount of old ice in the Arctic has decreased dramatically, because, you know, some of the ice used to just like exist pretty much permanently year round, and have been doing that for centuries. But that has broken down, and then fresh snow falls, but it's not old ice that's formed, it's new ice, but then that melts away again. And this year was the first time that a passage was open for a container ship to navigate through the Arctic. Okay, and so that would enable navigation between continents. And some people go, "Oh, that sounds pretty positive." Well, no, but again, you've got that benefit, you have to weigh that against potential costs in terms of changed weather systems. Okay. Now, there are some ways that we get greenhouse gases. There's a few different ways. Carbon dioxide, well, yeah, we breathe out. We're not going to stop breathing. Okay? Everything produces carbon dioxide in cellular respiration. Decomposition, things breaking down. Deforestation, okay, cutting down trees. Trees are a valuable source of, or a valuable resource in terms they suck up carbon dioxide, and they bind that carbon in their woody tissues. But if you're cutting trees down, and if you're burning the trees, or just cutting down forests and using them for farmland, then that valuable resource for soaking up carbon dioxide is gone. And of course, the classic burning fossil fuels is the greatest contributor. Every human on the planet on a day-to-day basis is burning things for energy, for cooking or for cleaning water or in industry and things like that. And we in the West are primarily burning fossil fuels and burning, of course, a lot of them. And that's resulting in this increase of carbon dioxide in the atmosphere. Now, methane, a very nasty greenhouse gas. It is something like 60 times more effective at trapping heat than carbon dioxide is. And bacteria in bogs and landfill produce methane. Livestock, cows, sheep, burp.
Is that poo? Livestock?
No, poo only if it's being broken down by bacteria, but burping and farting. Methanobes are the bacteria that live in the guts, yours included, that get a bit of food, and one of their waste products is methane. They're not particularly useful to you or organisms. They're not necessary for digestion. So they just live there, and they just extract a little bit of food from your waste, and they produce methane in the forms of burps and farts. You can vaccinate against them. So you can vaccinate cows and sheep so that they no longer burp and fart. And New Zealand, theoretically you could. In New Zealand, they do pay a little bit higher for their meat, so to pay for the vaccine for the cows and sheep to prevent them from farting. And nitrous oxide is another greenhouse gas. Bacteria in fertilisers are responsible for that one. So this one here is key, and this one really down here is important. This idea of burning fossil fuels, because we do burn a lot of fossil fuels, and that is contributing to this rise of about 2 parts per million of carbon dioxide per year. So we're up to about 408 or something parts per million of carbon dioxide. Can I change? Should be able to. There's only the 3 things to get down. Although deforestation is kind of important, because this is kind of sad. If you change the weather systems enough, forests die, and so you've got a bit of a twofer there. You've changed climate, forests die, which changes climate, which means forests die. Yes.
What, rice paddies?
Oh yeah, rice paddies. Well, where is my rice paddy?
In methane.
Oh yeah, I forgot. There, that's an important one.
What is
Rice paddies. Remember, a rice paddy is where you grow rice, and there's a lot of mud and water on top of it. Yes, and that's just an environment like a bog or a landfill, and just part and parcel of that, and is methane production. And remember, a lot of people globally eat rice. Okay, so a lot of agriculture in Asia is dedicated towards rice production, and so you have methane being given off. Okay. Now can I change?
Yes.
Yeah. Okay. Those are key ones. Okay. Now, how do we know about this history of atmospheric gases? And it comes down to ice cores. Allow us to generate continuous reconstruction of past climate going back at least 800,000 years. So what you're doing is you're going to Antarctica and you're drilling down through the ice. And the further down you go, the further back in time you're seeing. And from that ice you're able to pull out atmospheric gases that were trapped when the ice was formed. And so you can actually get a measurement of how much carbon dioxide was in the atmosphere 100 years ago, 1,000 years ago, 10,000 years ago, 100,000 years ago. And that's how you generate a graph like this. So it's not guesswork, you're not pulling these numbers out of the air, no pun intended. You are literally extracting data from ice cores in this sense. Okay? Concentration of greenhouse gases in layers of ice cores, calculate how much modern amounts of CO2 and CH4 and compare to those of the past, and compare past concentration of greenhouse gases to temperature. Okay? And so that's the basis of one of the conclusions in climate change. And there's a nice little video there from National Academy of Sciences on ice cores. We will watch that. We just won't watch that while we're making this particular movie. Okay? Is everyone clear on that idea? That ice cores, gases from the atmosphere are trapped when the ice is formed. And of course, it snows again and again and again and again, and the ice gets thicker and thicker and thicker and thicker, and so you're able to get this valuable information about the atmosphere from a long time ago. Okay. Can I change? Yes. Yeah. Okay. Now, let's have a look. I keep saying this. Let's have a look. Human impacts. How are humans going to be impacted by this changing environment. One of them, no, rising sea levels. Okay, so they have tide records that don't go back 800,000 years, obviously, but people have been sailing around for quite a while, and so we have some records for the past 100 years or so, and they show sea levels have increased by 10 to 20 centimetres during the past 100 years. Now, 10 centimetres is only, the length of an index finger. 20 centimetres is twice that. It doesn't seem like much, but that's a lot of water over multiple oceans. Now, warmer temperatures leads to melting ice, leads to rising sea levels. So that's the key idea. And this is for glacial thickness over time. So glaciers have slowly but surely working their way back up the valleys, but of course you need to think about the ice caps as well. So you've got glaciers, ice caps, and Greenland and Antarctic ice sheets. So most of the world's glaciers are receding. 4 of them are getting longer because greater evaporation means greater snowfall, so they're actually gaining a bit of mass. But the trend is for glaciers to get smaller. Glaciers very important for, in a lot of cases, there might be rivers associated with them, and of course in mountains, snow melt in mountains is responsible for rivers. Arctic sea ice is melting, 9% loss every 10 years. Okay? Thermal expansion is warm water takes up more room. So it's not just a matter of melting ice is leading to sea level rises, but of course the warmer the water, it will expand, and so that is responsible for sea levels increasing as well. And what happens when all of this is added up? Rising sea levels leads to flooding of low-lying regions, okay? And really important currents like the Gulf Stream change, and that can result in changed weather patterns. So, for example, a change in the Gulf Stream brings warm water to Europe, and that keeps Europe warmer in winter. I'm talking Europe, the many countries of Europe. This current of water is responsible for keeping them warmer in winter. If the Gulf Stream fails as a current, and it is failing, that has been measured, you end up with winters that are maybe 10 degrees colder. So global warming results in colder winters in Europe, which seems counterintuitive, but you need to understand that systems are important, okay? And there's some additional information there in that hyperlink. So ocean currents change because, so think of like ocean currents, they're driven both by temperature and by salinity, salt concentration. Now if you're dumping a heap of fresh water into the ocean, you're changing the salinity. And that's what's affecting the Gulf Stream. And it's changing the way it functions, and it may collapse as a current, which would again be disastrous in its own right. Okay. That's quite a bit of information. In summary, obviously, warmer temperatures leads to melting ice and thermal expansion. So melting ice and thermal expansion lead to rising sea levels. And rising sea levels lead to flooding of low-lying areas and ocean currents changing, okay, which can then affect weather in their own right. They might do other things like change fisheries if they're not bringing nutrients through, where you'll get large collections of marine life where a particular current is bringing nutrients through. And if that current collapses, the fish will move. They will try and adapt as best they can to either local conditions or they will shift. Okay. Can I change? Yeah. Okay. Now, I've got the same information there, so that's nice of me. Okay. There's just, that's been trimmed down the bottom a little bit, which makes it hard to see. But let's go. I'll just make it a bit bigger. So, melting of glaciers is, so the sea level rises we're seeing, 45% is melting of glaciers, thermal expansion is 38%, melting of Antarctic ice sheet is 13%, and ice loss from Greenland is 4%. So most of what we're seeing in terms of ocean ocean levels rising is glacial melt at this time. Okay. Now, right. Here's a bit more on human impacts and rising sea levels. You can get saltwater contamination when salt water is turning up where it would not otherwise be. Okay, so saltwater contamination of aquifers. It can have adverse effects on coastal ecosystems, water sources and human settlements. The big one, of course, is inundation or flooding of low-lying coastal regions, particularly during extreme weather events. So if you've seen the film footage from Florida recently, you get strong winds associated with a hurricane, heavy rainfall, and then this storm surge coming through. The strong winds drive water inland, and they can push a lot of water quite far inland. So even though the ocean's only 10 centimetres higher, which doesn't seem like very much, but if you're talking about a lot of ocean and some of these very strong winds, you can get storm surge going significantly farther inland. And that in turn displaces animals, kills plants, displaces communities. Coastal erosion becomes a huge problem. I was watching Grand Designs over the holidays with my wife, and there was this one particular house where they bought a cliff property that nobody wanted for next to nothing. And they did the math and they had it checked out, and they thought, this cliff will be here for about 100 years, maybe 80 years, give or take. And so they built their house as far back as they could. They go, well, we'll be long gone by the time the house falls in the sea. They hadn't even finished. They had one severe storm and they lost about 15 or 20 years of their cliff overnight. Okay, like they had a huge bite taken out of it and they were just in shock. And what they did to combat that was just dump landfill over the top of the cliff to try and build it up again and try and hold back. But it was a significant amount of erosion. So you can see here, low-lying regions are the ones impacted by rising sea levels. So the Maldives, a beautiful area of the world, very low-lying islands where, a mountain in the Maldives is 1.5 metres above sea level. And of course, so they are extremely susceptible to rising oceans and subsequently the storm surges. Yes?
Isn't it like the Netherlands, which are below sea level?
Yes, in some parts they are. And they've got a long history of building dikes to reclaim areas and things like that. But you need to be conscious of these things. Like, for example, coastal erosion. Coastal erosion for Australia would be disastrous. We love our beaches, and I think it would be heartbreaking for many Australians to maybe visit Bondi Beach and have that dramatically impacted by erosion. A big storm coming through, the water getting in further than it has before, and just taking out tens of thousands of tonnes of sand. Okay. And again, there's more information there. Now, this is a very important one. We covered it a little bit in the video we watched the other day. I'll highlight the information. Right. This is what bleached coral looks like. Okay? So it's obviously unhappy. Now, why does bleaching coral is in the process of dying? Okay? Now, an increase in temperature, okay, causes heat stress in corals. And remember, corals are a symbiotic organism. So you have the coral itself, and inside the coral lives algae. And the algae photosynthesizes, and that provides food to the algae and the coral. But if the water gets too hot, the coral ejects the algae, and they're just taken away by the current. So, and then the coral will die. So the coral relies upon the algae for photosynthesis, and this coral here has, so all of those colours you see that are associated with corals are because of this symbiotic algae. And in the event that the waters get warm, that gets ejected. So that's the first thing. The second thing is acidification. If you have more carbon dioxide in the atmosphere, you end up with more carbon dioxide in the water. And that ultimately produces carbonic acid. So the oceans become slightly more acidic. They've gone from a normal 8.25 to a normal 8.14. That doesn't seem like very much. Okay, in terms of numbers, it's not a very great change. But because of this increased acidity, marine organisms, coral, plankton, krill, shellfish, cannot form their shells. Okay, so the coral can't construct more coral. So at the moment, this particular coral here, there's no photosynthesis going on, so it's not being fed, and at the same time, the calcium carbonate shells can't be formed. So calcium carbonate shells are used by many marine organisms as their exoskeletons. And failure in this sense, in the terms of if they're unable to produce those shells, would result in massive die-offs of not just those organisms, but organisms that rely on them for food. Okay, so you'd have, when they talk about the worst outcomes for climate change, they say 90% of species dying. Okay, in a world of 4 or 5 or 6 degrees warmer temperatures, you would have ecosystems, entire ecosystems collapsing because of things like this. Krill forms the basis of many food chains, and for krill to collapse would result in everything further along the food chain suffering as a consequence. So those are the 2 reasons that coral... Now of course coral is just in terms of being selfish, 200 million people rely on coral for their incomes effectively. Okay, because coral reefs are valuable fish nurseries. So you'll want to put that down. Coral act as fish nurseries. So for about 20% of fish species. And if you don't have coral, those fish species, and the way they breed, they don't have that environment to do that anymore. Yes?
Is it, will they still be a nursery even when they're bleached?
Well, they break. So they're not being renewed, they're not a living organism anymore, so they become very brittle, and they just break and they no longer function. So they might kick along for a little while after, yes? Yeah. So, can I change now? Yeah. So you need to get this idea. As I said, 200 million people, and of course about 2 million Australians rely on the Great Barrier Reef and the tourist dollars associated with that, directly and indirectly, for income. And the failure of the Great Barrier Reef would be cataclysmic. And I can show you a map from, I think it was last year, where they used drones to map how much of the barrier reef had been impacted, and it was dramatic. Yes?
You said the coral released the algae.
Yes.
Where do the algae go?
They just end up in the ocean, in the currents, and and do what they do.
Right.
So can coral recover if they release the algae? They can, but what you have is if the waters stay warm, they can't recover. Yeah, they will not establish a symbiotic relationship again, so they'll die. Okay, and that's why at 2 degrees, 1.5 to 2 degrees, you lose 90% of your world's corals. They're a very delicate ecosystem.
People though can't go out to the Great Barrier Reef. Wouldn't that be wrecking the coral?
That's the funny thing. If you visit the Great Barrier Reef and snap a piece off, you are subject to heavy fines. But if you're a politician in government and do absolutely nothing to preserve this ecosystem, or worse, try to establish the Adani mine, and the world's largest coal mine, and you want to have coal ships moving through the Great Barrier Reef, that's fine. You're allowed to do that. But if you snap off a piece of coral, the full force of the law will come down on you. Okay, so the tourist operators who run through the Great Barrier Reef preserve that system as best they can, because it's critically important for their income. So yeah, you can visit the Great Barrier Reef, but there's becoming less and less reason to do so. Human impact number 3, desertification. Okay, it sounds delicious. It's the other dessert. It's desert. Okay, so fertile land becomes desert, typically because of drought or reduced rainfall because weather systems have changed. Okay? So, that's what's being emphasised here. It's projected that global warming will significantly impact agriculture because of changes in global weather patterns. It's still going to rain, okay? But in terms of Australia, they say a lot of Australia's rainfall, the projection is Australia becomes 40% or more drier than it already is, because a lot of our rainfall just lands in the ocean. It still rains, it just doesn't rain where it used to. You know? And that obviously would be a problem. Now, this is a, let's have a look at that, map and pull some information out. So, white is a 1 degree increase, 2 degrees, 3 degrees, 4 degrees increase. And you can see here, a 1 degree increase results in, what are we dealing with? US soybeans dropping about 5%. But, hey, increase for US maize and India wheat. So this is where one of those things where people go, oh, you know, when it was warmer in the past, they used to grow grapes in Britain. That's true. But, you know, you don't have take in Britain to a considerable extent, you know, because we've set up our global agricultural network to take advantage of the existing weather systems. And then, of course, at 2 degrees, you start to see impacts. Now, at 2 degrees, again, you've got an increase in India wheat and US maize, but there's a decrease here, there's an increase over here. At 3 degrees, oh sorry, I'm reading this backwards, aren't I? Shameful. That's negatives to the left, that's positives to the right. So let's start again. At 1 degree, US soybeans increase a little bit, Asian rice increases a little bit, but everything else drops. And then 2, 3 and 4 degrees, so at 2 degrees, that's what's projected and the way things are going. If we sit on our hands and really do nothing, we're looking at 1.5 to 2 degrees. If we keep sitting on our hands but then start working really hard, we might be able to hold it at 1.5 or 2 degrees, but if we do nothing at all, it gets a lot worse. So at 2 degrees, which is where we're projected to end up, if we really start to take solid action, we've got a 30% decrease in maize, 30% decrease in India wheat, US maize, and US soybeans aren't listed for that one, which is a bit weird. And so you can see here, as temperatures increase, you get a decrease in agricultural products. Okay, again because of changed weather systems. Okay, so there's the original document is there. This is the National Research Council. United States Academies of Science produces reports that shape policies, inform public opinion, and advance the pursuit of science. See, the interesting thing is, I've heard people say, oh, climate change isn't real. You've got these climate scientists, they're just trying to get government money, just printing any old thing. And it's like, the National Academy of Sciences, they are a branch of the government. These are scientists who are permanently on staff. Their only job, they get paid a salary. They get their $100,000, $150,000 a year. That's their salary. Whatever they produce, they get that salary. Their only job is to give governments expert scientific advice, to look at evidence and then present lawmakers with scientific advice. Now, the National Academy of Sciences of every developed country in the world are all screaming blue murder at the moment about climate change because, you know, the evidence is compelling, okay? Remember, these aren't people who get research money or anything like that. Their job is to provide expert advice to governments, okay? Now, extreme weather events is the fourth one. It's projected that global warming will impact agriculture because of changes in global weather patterns. You've got drought, colder winters because of things like the Gulf Stream, ocean currents changing, more frequent extreme storms, storm surge leading to damage to coasts and to coral reefs. Okay, let's see, natural disasters reported 1900 to 2008. So you can see here, this is the number of natural disasters reported. Now, let's be conscious that, of course, means of reporting natural disasters has improved. The internet now exists. It didn't exist for most of that graph, okay? But the number of weather-associated natural disasters has increased, okay? As I saw in the news recently about one location in the United States, they've had a once-in-a-century storm. So it's supposed to be, on average, a storm that severe every 100 years, as an average. But they've had 3 of those in the last 2 years. Okay, so you can't look at one storm and say that was caused by climate change, but you look at trends and increases in numbers of storms. Okay, now I will need that so I can mark my roll. Let's see. There's the enhanced greenhouse effect. Okay, now these notes here, you're not examined on this. You already know what the enhanced greenhouse effect is. You've already got that. And you can't be tested on this information here. But what this is showing is the fossil fuel industry has done a very good job, and politicians, of course, have gone along with this in Australia and certainly the United States, of presenting this idea that there's a debate in science about whether man-made climate change is a reality. Okay? And if you look down here, 55%, only 55% of people when I made this agreed, only 55% of people surveyed thought that scientists agreed that climate change, as we're seeing it, is being caused by humans. The environment's big, they would say. The atmosphere is huge. How can humans possibly impact that? Well, a few thousand humans in fishing boats have fished many species to extinction in the oceans. That's a few thousand people in fishing boats. Okay, we knocked out the ozone layer up to the 80s, but just using CFCs, we can impact the atmosphere. 97% or 98% of climate scientists agree that humans are responsible for the changes that we're seeing. To put that into perspective, and some scientists are very conservative in terms of the evidence they require, but to put that into perspective, more scientists agree, climate scientists agree. Now, I'm a trained molecular microbiologist. I am not a climatologist. Just because I'm a scientist doesn't mean I get to throw my 2 cents into the climate change debate, because that's not what I do. Bacteria, come to me. Climate, go to a climatologist. So 98% of climatologists agree that humans are responsible for the changes we're seeing. More scientists agree about that than they do about causes for cancer, certainly causes for dementia, Alzheimer's, things like that. I can find people out there who are trained scientists who will tell you that HIV, the disease, AIDS, is not caused by a virus. Okay? But just because I can find one nutty person over here who has a science background does not mean that there's a meaningful debate, because of the other 150,000 or 1.5 million scientists, medical scientists over here, who are saying most definitely this virus causes this disease. It's not a debate if you've got one person on one side and 10,000 or 100,000 people on the other side. You can't get tested on that though. That one definitely won't be tested. Okay. Now, I do need to mention this, but don't get confused. The ozone layer, 10 to 20 kilometres up, has nothing at all to do with climate change. But ozone low down in cities, emitted from cars, is a heat trapping gas. Okay? So it does make cities warmer than they would otherwise be. Okay? But that is a point of confusion. I swear, look, I'm telling you point blank, some of you in this classroom are going to get this wrong, and even though I'm going to say this more than once, you're still going to walk out of my classroom, I don't know for what reason, and you're going to vomit out a word salad in the exam, and you're going to say, oh, climate change is caused by a hole in the ozone layer. And I'm just going to cry when I read that in your exam. Okay? That's my only meaningful response at that point. Well, it's meaningless. The ozone layer is an example of humans changing the atmosphere. You know, the ozone hole. It has nothing at all to do with greenhouse gases, carbon dioxide, water vapour, nitrogen oxide, and methane trapping more heat. from the sun. These are very different things, okay? Please don't get them confused. But in a city, low-level ozone, which doesn't get to the ozone layer, will trap heat. Okay, now, how will this sort of thing affect Australia? Okay, because there's an element of, well, let's see. Now, scientists generally agree that during the next 100 years, temperatures are going to go 1 to 4 degrees. Okay, the CSIRO said 2 degrees by 2030 and an increase of 6 degrees by 2070, which would be a nightmare scenario at 6 degrees. Now remember, if you're cooking muffins and you're supposed to cook them at 180 but you do 186, they're not really going to change very much. But we're talking about energy in a system that can change weather, okay? And change the way oceans work. Big systems, okay? So, the language here says more hot days, fewer cold days, increased rainfall in the northeast, less rainfall in the south, more bushfires, more destructive cyclones. It sounds pretty benign, but it's not. One report I saw from Monash said by 2050 there would be no bushfires in Australia because there would be no bush. Okay, it's just been hit too many times in repetition so that the bush cannot recover. Okay, and of course we've already seen the Great Barrier Reef being dramatically impacted. Locally, Bendigo, you'd expect our summers to be kind of like Mildura. So you get these 46, 47 days and you get a few of them lining up. More evaporation, generally drier environment, less rainfall, so you end up in permanent water restrictions and you go on from there. Okay, so now I'll talk a little bit about Linus, but this is not testable. So let me just see if I've got, oh yeah, we've got that. Okay, so I'll stop the movie here.
Oh.
Yeah.